Okay, this is cycle 3, week 22 of Fine Arts. I'm using the Foundations Guide. So far this quarter, we have talked about fairly simple probabilities, such as the chance of something happening on one try. Often though, we have more complicated questions that are harder to solve mathematically. So let's examine the blueberry pancakes problem to see a great example. Okay, so we have made enough batter for 6 pancakes. I have my 6 pancakes here, and I've labeled them 1 through 6, okay? Number 6 is right here. And I have 15 blueberries that I want to distribute to these pancakes. But the blueberries are not guaranteed to distribute evenly across all the pancakes. In fact, we're going to randomly distribute them and see where they land. We're going to roll a die and see where our first blueberry lands. If it lands on a 4, then we're going to put a blueberry on the number 4 pancake, okay? Our die has 6 sides, so each of our 6 pancakes has an even chance of getting a blueberry. It has a 1 in 6 chance of getting a blueberry, right? So why don't we find out what happens when we roll this die 15 times and see what the distribution is. So I love this big die to use in class. I found these on Amazon. For right now, for my video, I'm going to use a little one. I don't quite have the space for such a big giant one. So that time I got a 1, 2, 2, 1, 3, 1, 3, 1, 3, 3, 1. My goodness. Going to the floor. 1. Now let's use our big one since I lost that one. 2, 3. My goodness. 6. I got a 6. Excellent. So now I distributed my 15 blueberries, and man, it was really heavy on the 1, 2, and 3, wasn't it? I got a 1 on number 6, but number 4 has none, and number 5 has none. You'll probably get different results when you try it. But let's just talk about our results. How many pancakes got at least 4 blueberries? This one has at least 4. This one has at least 4. This one has 5. This one has 6. So 2 of them have at least 2 blueberries. How many have less than 2? How many have less than 4? 1, 2, 3, 4. 4 of them have less than 4. How many pancakes got more than 4? 2 got more than 4. How many got exactly 4? None. None of them got exactly 4. Are there any outliers, meaning results that don't seem to fit the normal pattern? Wouldn't you say these are outliers with 0? Does 0 seem like, was that surprising? Did you expect it to be 0? To get 0 when there was an even chance on the die of getting 1 out of 6 chance of getting all the numbers? Yeah, I feel like those were probably outliers. What do you think the chances are of getting 4 blueberries on 1 pancake then? Based on our results here, what is our chance of getting at least 4 blueberries on 1 pancake? So back to our probability equation. We have our desired outcomes over our total outcomes. So if we have 6 pancakes, then how many of them will have at least 4? We think 2. Based on our results, we think 2. And big kids, if we reduce that, 1 out of 3 chances, or 33% chance of getting at least 4 blueberries in a pancake. Those are not super high odds. We could keep going with this by doing 15 more rolls and adding 15 more blueberries and see if that changes anything. So that's what I recommend you do now. Grab your die again, roll 15 more, add your blueberries, and see if it changes your results. And ask these same questions again. How many have more than 4 then? And see what happens to the probability and to the chances of getting pancakes that have at least 4 blueberries. That's what we're looking for. Our desired outcome is pancakes with at least 4 blueberries. So we started with 15 rolls and 15 blueberries, and then now we're going to go for 30. So we're going to do 15 more, so we have a total of 30 blueberries, 30 rolls with that die, and you guys can do that as a class all the way to 30, or you could do 15 as a class, and then you can pass out this wonderful worksheet from Nicole Liam Yang's worksheet that's on CC Connected, and kids can work either individually or in pairs. I think pairs would be good to do this all from scratch, from 1 roll all the way to 15, and just draw little blueberries on their blueberries for 30 rolls, 30 blueberries, and see what they get for their outcomes, and then you guys can compare as a class. So this will be really neat to see what the chances of getting 4 blueberries on 1 pancake are, and what that probability would actually be. Because calculating this probability for real pancakes is actually pretty difficult. Factors change, like the numbers of blueberries decreasing in the mixing bowl, but drawing a model is a great way to help us start to see how distribution affects data, not only how it affects breakfast. So that's week 20.